Nano, nano, nano. Seems like everything in the world today is nano. Nano cars, nano cryptocurrency, nano shampoo, nano water, nano hearing aids, nano knees, nano homes, nano clothes. The list goes on. But what exactly is nano? And why should you care? Hi, I'm Lenny. I'm the Vault Guy. I'm a cell biologist and a nanotechnologist. My passion is a common particle of the human cell called a vault. Vaults live in a nanoscale world. So, before we can talk about vaults, we need to understand what nano is. Stick around and I'll tell you a little about nanotechnology as well. Today I have 3 simple goals. First, I'm going to explain why the metric system is used to measure things that are so small they can't be seen by the naked eye. Second, I'm going to help you understand the relative size of very small objects, things you hear about every day like cells and viruses and drugs. Finally, I'm going to explain to you why you should care about nano. You know, there are 2 basic systems used to measure length in the world. Most countries and all biologists mainly use the metric system. Only the United States, Liberia, and Myanmar use the imperial system to measure stuff. The imperial system uses inches, feet, yards, and miles, while the metric system uses millimeters, centimeters, meters, and kilometers. For science, the metric system is just better because it's easier to describe very small things. Allow me to explain. Here's a ruler with inches on one side, the imperial system, and centimeters on the other side, the metric system. You know, the inch was originally the width of a man's thumb. In the 14th century, King Edward II of England ruled that an inch is equal to 3 grains of barley placed end to end lengthwise. The foot was originally the length of a man's foot. Taken together, that means there are 36 barleys or 12 thumbs in a foot. The ruler further divides each inch into 16 equal parts. Why 16? I think this is done on rulers so you can see the half inch, quarter inch, eighth inch, and 16th inch gradations. Here's a tape measure with inches on one side and centimeters on the other side. If we measure out 3 feet, we get to a yard. In the 12th century, King Henry I of England fixed the yard as the distance from his nose to the thumb of his outstretched arm. Wow, 3 feet. I guess maybe in a previous life I was the King of England. So for a lot of people, woodworkers, carpenters, mechanics, both the metric system and the imperial system work great. In fact, for everyday common uses, some folks prefer inches and feet over centimeters and meters. Personally, I find it easier to visualize someone's height if you told me they were 6 feet tall as opposed to 182 centimeters tall. Where the metric system gets very useful is when you want to measure things that are much smaller than an inch. On metric rulers, a meter is divided into centimeters, which are 1/100th of a meter, and each centimeter is further divided into 10 parts. Each of these parts is 1/1000th of a meter. Each part is called a millimeter. When you divide a millimeter into 1,000 equal parts, one part is called a micrometer. And when you divide a micrometer into 1,000 equal parts, one part is called a nanometer. So now we are back to nano. Nano refers to a size, which is a nanometer, abbreviated NM. 1 nanometer is 1/1000th of a meter, or 1/1,000,000th of a millimeter. To visualize nano, let's start with a couple small everyday objects, say a penny and a pin. A penny is about 20 millimeters across, and the width of a straight pin is about 1/2 millimeter. Cell biologists want to understand what goes on inside cells, so they want to look inside cells. Cells are measured in micrometers, and things inside cells are measured in nanometers. You can use a regular light microscope to see things that are micrometers in size. Why, today you can buy a decent light microscope on Amazon for less than $100. And with a light microscope, you can see an individual cell. Here's what a drop of blood looks like viewed in a light microscope. You can see the individual cells. But the best you can do with a light microscope is to see things that are a few micrometers across, like blood cells, which are about 8 micrometers across. In order to look inside cells, we can use an electron microscope. Electron microscopes, or EMs, are used to measure things that are nanometers in size. Unfortunately, the last time I checked, you couldn't buy an EM on Amazon. A decent EM will set you back $500,000 or more. Fortunately, I work in a research center that has several EMs. Since I want to show you a sample of blood in the EM, I prepared a drop of my own blood so that it could be viewed under the electron microscope. I followed a procedure that includes a stain that allows you to see the different parts of a cell. A drop of blood is encased in a soft plastic, which is cut into thin sections using a machine called a microtome. The sections are very small and very thin. To put them in the EM, they're placed on a tiny copper screen called a grid. Here's one of those grids shown to the right of the penny, so you can get a feel for its size, which is about 3 millimeters across. I put the grid with the plastic section of my blood into the scope. I focused at the lowest magnification. It was about 500 times, and I took a photo. You can barely see the plastic slice on the honeycomb-shaped grid. I'll highlight it for you here. To allow you to judge the actual size of things, the microscope puts a bar in the photo, called a scale bar. Scale bars are rulers to show the size of the objects in the picture. This is like the mile scale bar that usually is shown at the bottom of a map. Here the scale bar is 500 micrometers in length. If we magnify it more, you can see the plastic slice clearly. And if you look really closely, you might be able to see the blood cells embedded in the plastic. Here the section is magnified about 5,000 times. Notice the scale bar here is 20 micrometers. You can now see the blood cells. If we increase the magnification to 50,000 times, you can finally see individual cells. Here the scale bar is 1 micrometer. There are only 2 cell types in the picture. The nondescript grayish cells are red blood cells, which are flat disc-shaped cells, which can look round if they're cut perpendicular to the flat side, and cigar-shaped when they're cut through the thin direction. The spongy-looking cell left of center is a white blood cell. If we magnify the white blood cell a bit more, we can see the 2 major cell compartments. The nucleus, this large area in the center of the cell, highlighted here, and the cytoplasm, the area around the nucleus. The different components of the human cell will be the topic of my next video. However, this photo of a white blood cell is now magnified enough that you can finally see something that is 100 nanometers in diameter. I've superimposed a 100 nanometer yellow sphere in the cytoplasm indicated by the arrow. Let's look at a higher magnification of something that is the size of this yellow dot. How about a virus? Turns out there are millions of different viruses in nature, and they range in size from 10 to 1,000 nanometers. Here's a common virus called adenovirus, viewed in the electron microscope. These viruses are about 100 nanometers in diameter. The 3-dimensional structure of adenovirus has been determined using a method I'll discuss in another video. Here's the 3D structure. Another virus that is similar in size is currently the most famous virus on the planet, the SARS-CoV-2 virus, the one that causes COVID. These protrusions all over the surface of the SARS virus are called spike proteins. They're about 25 nanometers long. A large protein like an antibody is about 15 nanometers across, while an average-sized protein like hemoglobin, the oxygen-carrying protein found in red blood cells, is half the size of an antibody, about 5 nanometers across. Interestingly, red blood cells contain about 280 million hemoglobin molecules. So how big is a small molecule? Aspirin is considered a small molecule drug. Aspirin is less than a nanometer across. And finally, for our size comparison, one of the smallest molecules in a cell is water. A water molecule is composed of 1 atom of oxygen and 2 atoms of hydrogen. It's only 0.27 nanometers in diameter, almost 20 times smaller than a hemoglobin molecule and too small to see in the electron microscope. And the smallest atom is hydrogen. The diameter of a hydrogen atom is about 0.1 nanometers. We've been diving down to smaller and smaller sizes with the goal of giving you a feel for what nano really means. One last analogy, let's return to a common virus, the polio virus. Polio virus is about 30 nanometers in diameter. If you could blow up a single polio virus 10 million times, it would be approximately the size of a soccer ball. If you could blow up a soccer ball 10 million times, it would be the size of the moon. Okay, so hopefully you now have a feel for nano and the nanoscale. But why should you care? I think you should care because of the potential of nanotechnology. Simply stated, nanotechnology is the manipulation of stuff at the nanometer scale to produce new stuff like structures, materials, and devices. For cell biologists like me, nanotechnology is enabling a field called nanomedicine, where scientists can engineer materials at the nanoscale to create new drugs, new diagnostics, and new devices. Nanomedicine will allow us to cure diseases and infections and treat injuries and even cure genetic disorders. The technology I'm interested in is focused on manipulating a natural nanoparticle called a vault. Today's video was the first step. Next, I'll try to explain vaults by expanding your knowledge of cells, cancer, and particular biologic and environmental problems where vaults might be useful nanoscale objects. I'm Lenny Rome, the Vault Guy, and I hope you will join me as we further explore vaults and the nanoscale world.